Okay, hello everyone. So we're going to continue our discussion on random variables and probability distributions. So this is the last slide I have presented in my last discussion. So for today, I'm going to discuss a new topic. Okay, so this will be the part three of our topic on random variables and probability distributions. So here is the slide, our first slide for part 3 of our topic. So we have Poisson distributions. Okay, so previously I have discussed binomial distributions. Okay, wherein binomial distribution is the probability distribution of a binomial random variable. Okay, so this time we'll talk about Poisson distributions, another probability distribution. So what is Poisson distribution? So a Poisson distribution is a discrete probability distribution, just like the binomial distribution. It is also discrete. That is constructed by performing a Poisson experiment. So in binomial distribution, we are performing binomial experiment. No, this in this topic, Poisson distributions. So we are to perform Poisson experiment and the Poisson distribution is then constructed. Okay, so in here we have Poisson experiment definition. So it is a random experiment that yields numerical values of the Poisson random variable. Okay, so random experiment that yields numerical values of the Poisson random variable. Okay, so that is a Poisson experiment. Okay, so take note that Poisson random variable is a discrete random variable. Okay, so we now proceed. So when we talk about Poisson random variable, as I said earlier, it is a discrete random variable whose values are the number of outcomes in a given time interval or in an specified region. Okay, such as distance, length, area, or volume. Excuse me. So we have, so that is Poisson random variable. So it concerns about number of outcomes, no? So number of outcomes in a given time interval or in a specified region, and that region could be distance, length, area, or volume. Okay, so that is Poisson random variable. So in here we have the probability of the Poisson random variable x is is equal to a certain value x is given by the formula. Okay, so here's the formula. So this is the probability of the Poisson random variable x equal to a certain value x, a specific value. So this is the formula of it. Okay, so that is equals to e to the negative mu. Okay, so this is the Greek letter mu. No, so Greek letter mu. Okay, and then we have mu to the x over x factorial. Okay, this is true for x equals to 0, 1, 2, and so forth. Okay, where n is a non-negative integer. So meaning, if it is non-negative, 0 and all positive integers. Okay, so where okay, so when we have this symbol mu, this is equals to this notation. Okay, so this is the Greek letter lambda. Okay, lambda, Greek letter lambda. Okay, So mu is equals to lambda times t. Okay? So what is the interpretation of mu? It is mean or average number of outcomes in a given measurement. No? So mean or average number of outcomes in a given measurement. Okay? So later we'll have an example to this to better appreciate what I am discussing right now. No? And then, so lambda is the mean or average number of outcomes per unit of measure. Okay? So mean or average number of outcomes per unit of measure. Okay? So it could be per unit time, per unit length, per unit area, or per unit volume. Okay? And then we have T is the measurement. So it can be time interval, length, area, or volume. No. Time interval, length, area, or volume. Okay? And then, so here's the problem on Poisson distributions. Okay? So to better understand my discussion previously, so let's answer a problem. So here's the problem. The number of cars arriving at the gasoline station follows a Poisson distribution with the mean of 3 cars for every 10 minutes. What is the probability that exactly one car will arrive in the next 10 minutes? Okay, let us analyze the problem. So given we have the mean of 3 cars, okay? The number of cars arriving. So the average is 3 cars. The average number of cars arriving at the gasoline station. So when we talk about average number, we are pertaining to the mean. Okay? So we have 3 cars. And this will now be the notation mu. Okay? Every 10 minutes. So this is the time interval. Okay? Every 10 minutes. So our time interval is 10 minutes. So every 10 minutes, yung bilang ng mga cars na nasa gasoline station, yung arriving at the gasoline station ay 3 cars kada 10 minutes yung bilang. Okay? Na nag-arrive dun sa gasoline station. In average, no? So what is the probability that exactly one car will arrive in the next 10 minutes? So ngayon, ano daw ang chance na meron tayong isang car na mag-arrive sa gasoline station sa next na 10 minutes? Okay? Kung yung average ay 3 cars every 10 minutes, ano ang probability na isang car yung mag-arrive in the next 10 minutes? So that is our concern, no? So required the probability that exactly one car will arrive in the next 10 minutes, no? So in that case, the solution to the problem is this. We let x be the random variable for number of cars that will arrive in the next 10 minutes. Okay? So we let x be the random variable for the number of cars that will arrive in the next 10 minutes. Okay? So in that case, our random variable no, pertains to the number of cars. Therefore, it is discrete, right? Wala naman kasing 1.5 cars, wala naman 2.3 cars. So, exact number, right? Whole number, right? So, this is now the formula. So, the probability that the random variable x is equal to a specific value x is equals to E. So, take note that E is 2.71828. Okay, 2.71828 and so forth and so on. In the calculator, This is the value, right? So it is a non-terminating, non-repeating decimal number. Therefore, it is an irrational number, right? So we have e to the power of negative mu multiplied by mu to the power of x, okay, where x is the value of the random variable over x factorial. So we have mu as the mean number of cars, okay. So in that case, applying the formula, we have the probability that the random variable x is equals to 1, and that will be equal to e to the negative 3 multiplied by 3 to the power of 1 all over 1 factorial. And that will give us 0.149. Okay? So the probability that exactly one car will arrive in the next 10 minutes is 0.149, meaning there's a 14.9% chance that exactly one car will arrive in the next 10 minutes. That is the interpretation. Okay? This is true provided that the random variable follows a Poisson distribution. Okay? So, in that case, we can now proceed with another example. So we have an example, an average of two cars arrives at the highway toll gate every 10 seconds. Okay? An average of two cars arrives at the highway toll gate every 10 seconds. If this rate is approximated by a Poisson process, what is the probability that exactly three cars will arrive in a 10-second period? Okay, so let's analyze. We have given. So we have the average is given. We have two cars arrives at the highway toll gate. Okay, every 10 seconds. So that's the time interval, 10 seconds. So if this rate is approximated by a Poisson process, so meaning the random variable follows a Poisson distribution. Okay, so what is the probability now that exactly three cars will arrive in a 10-second period? Okay, that is our concern because the average number of cars that arrives at the highway toll gate every 10 seconds is two cars, right? So what is now the probability that there will be three cars in a 10-second period? So solution to the problem. So we let x be the random variable per number of cars arriving in a highway toll gate in a 10-second period. O question natin, paano ko nalaman na yung random variable ay number of cars arriving in a highway toll gate? Okay, unang tanong, ano ba yung hinahanap sa problem? What is the probability that exactly three cars will arrive in a 10-second period? So, exactly three cars. Ano yung three cars bilang ng mga cars? Therefore, the random variable is the number of cars. Okay? And this is the time interval. Okay? This is the time interval. So, now, we proceed. So that's our random variable, number of cars. And we have the average number of cars is 2. So recall now that this is the formula and we are to apply the formula. So the probability that x now is equals to 3 in a 10-second period. Okay, so we have e to the negative 2 multiplied by 2 cubed over 3 cubed. Okay, over 3 factorial. No? So we'll arrive with an answer of 0.180. Okay, So that's the answer. So there is an 18.0% chance that 3 cars will arrive in a 10-second period. Okay? So let's answer number 3. The owner of a tree farm specializes in growing pine trees and selling them for Christmas trees. They are grown in rows of 50 trees, and the owner has found on the average, about 4 trees per row will not be suitable to sell. Assuming that the Poisson distribution is applicable here, find the probability that the row of trees selected for shipment will contain 2 unsaleable trees. Okay, let us analyze. So we have the owner of a tree farm, no? Specializes in growing pine trees and selling them for Christmas trees. Okay? Now they are grown in rows of 50 trees. Okay? Rows of 50 trees. Okay? So therefore, what is my mean? Or should I say rows of 50 trees? Okay? So for every row, there will be 50 trees. And the owner has found on the average about 4 trees per row will not be suitable to sell. Okay? So 4 trees per row will not be suitable to sell. That's why lambda is equals to 4. Okay? So let's go back to our previous slide to better understand this. So when we talk about T, that pertains to measurement. It could be time interval, it could be length, it could be area, or it could be volume, or anything, no? That has something to do with measurement. Okay? So in that case, our measurement is this one. Our measurement is row. That is our measurement. Okay? Row. So that is now T. Okay? T equals to 1 row, in short. So we're in lambda is simply mu over T. Okay? Simply mu over T. That's why this is 4 trees per row. 4 is 4 trees per row. Okay? 4 unsaleable trees per row of trees. To be specific, unsaleable trees. Okay? So there in a row of 50 trees, there will be 4 trees that are not suitable to sell. Okay? There will be 4 trees that are not suitable to sell. Therefore, they are unsaleable. Okay, so this is the average. 4 unsaleable trees per row of trees. Row of trees is your measurement. Okay, so this is your measurement. Okay, that is 1 row. 1 row of trees. Okay, containing 50 trees. Containing 50 trees. That's your measurement. So that is T. So this is T, 1 row of 3. Okay, 1 row of trees. Okay, 1 row of trees. Okay, so this is the average for. Now for every row of trees, the average unsaleable number of trees is 4. Okay, so the owner has found on the average about 4 trees per row will not be suitable to sell. Okay, so in that case, required in the problem is this. Find the probability that the row of trees selected for shipment will contain two unsaleable trees. Okay? So the probability that two unsaleable trees in a row of, so we are to find the probability, no, having two unsaleable trees in a row of trees. Okay? Ano ang tsansa na dalawang puno na hindi mabebenta yung sa yung sa isang row ng trees na 50 lahat ng bilang? Ano yung probability na dalawa dun sa 50 na yon na nasa row, okay, ay hindi mabebenta? Kung yung average na hindi nabebenta na trees dun sa row na trees na 50 na 50, no, na 50 trees, okay, so 4 out of 50, yung 4 yun yung hindi nabebenta in average. Ano ngayon ang probability na dalawa ay hindi mabebenta dun sa row of trees na 50? Okay? So that is our concern. So solution. So dahil ito ang hinahanap, probability na there will be two unsaleable trees in a row of trees. So therefore, ang random variable mo ay number of unsaleable trees, no? Random variable for number of unsaleable trees in a row of 50 trees. Okay? In a row of 50 trees. Kasi 50 lahat, kada row. No? So recall, no? So this is the formula. And take note, ang mu natin ay lambda t. Right? Kasi ang lambda ay mu over t. Okay? Average over yung measurement. Yun yung ating lambda. Okay? Yun yung ating lambda symbol. Okay? Average per measurement. So in that case, so in terms of lambda, no? E raised to negative lambda t to the power of x over x factorial. So here's the, so ganyan yan ah. Ayan. Okay? So yan yan. In terms of lambda t siya, yung mu. Okay? Negative lambda t to the power of x over x factorial. So the probability that there will be two unsaleable trees is equals to e to the negative 4. Okay? So ano yung lambda t? 4. Kasi 4 unsaleable trees multiplied by 1 row of 3 ay 4. Diba? Kasi t is 1 row. Diba? So that is mu equals to lambda is 4 unsaleable trees per row of trees. That is lambda multiplied by time. Time interval. Sa case na to, hindi siya time interval. Multiplied by measurement. Measurement is 1 row of trees. Okay? 1 row of trees. Okay? So cancel, kaya 4 ang sagot. Mu now is 4. Kaya 4 ito. Kasi lambda t is 4. Ito rin ay 4. Okay? So that's all. Then the final answer is 0.147. So that's the probability that in a row of 50 trees, there will be two unsaleable trees. So which is 0.147. Okay? So let's now proceed to number 4. Number 4, from past experiences, the basketball club owner knows that about 4 games on average will have to be postponed during the season because of rain. Find the probability that this season no games will be postponed because of rain. Okay, let's analyze. So given We have lambda equals to 4 for postponed games per rainy season. Okay? From past experiences, a basketball club owner knows that about 4 games on average. Okay, so this is the average 4 games that will be postponed, no? During the season because of rain. So because of rain, per rainy season. So per rainy season, this is your measurement, no? This is your measurement. So that is T. Okay? That is one rainy season. That's your measurement. This is your average or mean. Okay? This is your mean. Okay? Mean over measurement. So mean over measurement. Okay? Now, will have to be postponed during the season because of rain. Find the probability that this season no games will be postponed because of rain. So, anong daw yung tsansa na walang mapopostpone na game? Okay? Because of rain, walang mapopostpone. Considering na apat yung napopostpone na game, no? Because of rain. Okay? So, because of rain, apat yung napopostpone for every rainy season. Okay? For every rainy season. So, therefore, T is one rainy season here, no? And then, here's the requirement. No games will be postponed in the rainy season. Okay? So, solution. We let X be the random variable for number of games postponed in one rainy season in a basketball game. Okay? That will now be the random variable for now. Our random variable will be number of games postponed in one rainy season in a basketball game. So if this is our random variable, so what is the probability that X now is 0? That is our concern. Okay? So we recall the formula, and mu is equals to lambda t, and that is for postponed games. No? And this is now the solution. The probability that X is equals to 0 because no games will be postponed in one rainy season. So therefore X is 0 because a random variable is now concerns about number of games postponed in one rainy season in a basketball game. So we have now e to the negative 4 multiplied by 4 to the power of 0 over 0 factorial. No? Because X is 0. So 0 factorial is 1, right? And what will be our final answer? Our final answer is 0.0183. So that's it. So meaning there is a 1.83% chance that there will be no postponed games in that season because of rain. Okay? So maliit ang chance na walang mapopostpone na game. Maliit, 1.83%. Okay? So that's it, no? So that's our answer. So our answer is correct provided that our random variable is a Poisson random variable. It follows Our random variable follows a Poisson distribution. Okay? So we can now proceed. So we have five records in the city of Manila shows that the average number of stores closing in a year due to loss is 2. What is the probability that there will be 4 stores closing this year because of loss? Okay, let's analyze. So given, so we have lambda is equals to 2. 2 what? 2 closing stores per year. Okay, the average number of stores closing in a year. So 2 closing stores per year, that is lambda. Okay, so that is average per unit measurement. Okay, lambda. So we have now t equals to 1 year. So this is our measurement, which is a time interval, 1 year. Okay? So ngayon, ang hinahanap, ano daw ang tsansa na apat yung magko-close na mga stores in a year dahil sa pagkaduge, no? Lalo na sa panahon ngayon na 2021, pandemic pa rin, di ba? So, given that, ano yung probability na for stores closing in a year due to loss? Okay, let's answer. Solution. Let x equals to the random variable for number of stores closing in a year due to loss in the city of Manila. So, yun ang ating concern. Okay, yun ang ating random variable, number of stores closing in a year. Kasi ang tinatanong is probability that there will be 4 stores closing. Therefore, a random variable mo ay number of stores closing, right? In a year. So, recall, there's the formula for Poisson distribution. Okay? And this is our mu. Mu equals to lambda t equals to 2 closing stores. Okay? Lambda is 2 closing stores per year multiplied by time interval of 1 year, we get 2 closing stores. So this is the average. And we apply the formula. So the random variable is equals to 4. 4 stores closing in a year due to loss. So what's the probability that there will be 4 stores closing in a year due to loss? If the average number of closing stores in a year is 2. So the answer is 0.0902. So there's a 9.02% chance that there will be 4 stores closing in a year due to loss in the city of Manila. Okay? So that is our answer. So that ends my presentation. Okay? Good day, everyone.